Okay, Assalamualaikum. My name is FARHAH ATIQ. My number metric is B0820104045. Okay, I will present for part 1 for mechanical system. Okay, for mechanical system shown in figure 1, we are going to find the equivalent transfer function, where is G1S and G2S. So we are looking for figure 1. For this figure, we are using equation motion by infection. Okay, first of all, we need to find total force of X1 and X2. Okay, by using the equation of total force, we can get a force at M1, FV1, FV2, and M2, which is A for M1, B for FV1, and C for FV2, and D is for M2. Then from the parameter had given, okay, from this set parameter 1, we can substitute the value for A, B, and C, A, B, C, and D. Okay, for example, we put the substitute for parameter 1, which is A equal to S2, S square plus 2S plus 2, B equal to C equal to negative S plus 1, and D equal to S square plus 2S plus 1. Okay, next, we are using matrix equation to solve the equation of A, B, C, and D. So we just put the value of A, B, C, and D into matrix equation. Then solve it until we got the result of x1 and x2. After that, to find G1S and G2S, we only divided result of x with determinant, and we got the answer of G1 and G2. Same goes to parameter of 2. We are using the same equation. Next, I will pass the calculation of part 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabilah binti RODZI. So I'm doing for part 2 calculation electrical system. So given this is parameter 4 and 5 and the value. So this is the original circuit that given. So we the calculation. So basically we must transform to Laplace circuit is in terms of S. For resistor is maintained R1, R2, and R3. And for capacitor and inductor, we change it as 1 over Cs and inductor L as. So, then we apply loop 1 and loop 2. So, for loop 1, we get R1 plus 1 over C, 1S, plus R2 plus 1 over C, 2S, plus ICS minus R2 plus 1 over C2S, I2S equal to S. Okay, so for loop 2, from here, negative R2 plus 1 over C2S, I1S plus R3 plus R2 plus IS plus 1S, I2S equal to 0. This is LS. So after that, use metric form. Based on equation, this loop 1 and loop 2 we get. Then we apply Kramer rule and solve it for S1 and S2. So we get S1 and S2. After that, we transfer function to B1 to substitute for parameter 3, 4 and 5. So after we get transfer function this, we substitute for parameter 3 from this table parameter 3, 4 and 5. The value we substitute and we get for parameter 3 x2 bracket 1 plus s over 2s3 plus f2 5s of power to 2 plus 4s plus 1. So we get this for parameter 3 and parameter 4 we get x2 bracket 2s plus 4 over 4x to the power of 3 plus 8s to the power of 2 plus fs plus 1. So the last one is parameter 5. The answer for parameter 5 is s3 plus 2s to the power of 2 over 5s to the power of 3 plus 16s2 plus 30s plus 2. We substitute and we solve it to get the answer for parameter 3, 4 and 5.
Okay, Assalamualaikum. My name is AMIRUL RASHID. So today I would like to present about the simulation for part 1 and part 2. So as you can see right here, this is the part 1 for our simulation. And first of all, we need to identify our set parameter system, which is M1 is 1, K1 is 1, FP1 is 2, and then for the rest is also 1. And next up is we need to use a symbolic mask. For the coding is SYMS. So we apply two different decimal symbol, which is S and F. And then we apply the array function based on set parameter system. So we apply two input, which is A1 and A2. And after that, we apply the output signal for the x1 and x2, which is we apply the determination for the A1 and A2. For first signal, x1 equal to determination A1 divided by determination A. And then for the A2, determination A2 divided by determination A. So as you can see, this is the result for the output signal by using the determination. And then after we get the result like this, we need to apply the transfer function, which is we need to apply the numerator, denominator, and then SYS and step plot for display our output signal, and also the second one. So, and now I would like to try run this program. So as you can see right here, we have two output, and for the blue one is the X1 signal, output signal, and for the red one is X2 for output signal number 2. And then we go next to the part 2. For the part 2 is pretty similar to part 1, but instead we need to find only one output signal, which is I2 right here. So First of all, as usual, we need to identify our set parameter system, and then we apply the SYMS for two symbolic mass, and then we apply array for based on set parameter system, and then we find the only one output is signal, which is I2, where we need to determine A1 and A, and then we also need to find BL to identify our output signal. After we done, we need to find the transfer function based on the output signal that we have been determining for A1 and A. So as usual, we need to key in the numerator, denominator, SYS, and step plot for display our output signal. Now let me try the second program. So as you can see here, this is the result for the I2 output signal. So as you can see, they show the output for I2. So that's all for today. Thank you.